We're going to take a look at sine, cosine, and tangent, but this time from trigonometric function perspective. Now, if you have a point on the coordinate plane, which is x comma y, and your angle then goes from the positive x-axis to the origin and then to the point xy. The sine of that angle is y over r, where r is basically your hypotenuse on your right triangle. And to find your hypotenuse over here, you would go do the Pythagorean theorem. You go x squared plus y squared equals r squared, solve it for r, and that's how we get this. Now notice, it's a positive in front of our square root here. So that means r is always positive. Please make note that r is always positive. R is never negative. Now, if you were thinking of Sohcahtoa with this triangle, you go to your angle. Sine would be opposite, which is y, over your hypotenuse is r. So you get the same thing as you would with Sohcahtoa. Cosine is x over r. If you thought of Sohcahtoa here, you go to your angle, you do adjacent, which is x, over your hypotenuse, which is r. So Sohcahtoa does the same as this. Tangent, if you were using Sohcahtoa, would be opposite of y over adjacent, which is x. So tangent's y over x, and that's what you have right here. Then you have the reciprocal functions. Remember, the reciprocal sign is cosecant, so that's y over r. Reciprocal of cosine is secant, so that's r over x, and the reciprocal of cotangent is tangent, so that's x over y. Another thing that you're going to need to be aware of are these three main Pythagorean theorem identities. Sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared, and secant squared plus 1 equals tangent squared. If you are interested, I can explain where these come from and how to get from one to the other in class, so just let me know. So here, you're given a point, and you're asked to find your 6 trigonometric functions. So what I would do is I would first of all draw my xy axes and plot my point. Go 8 to the right and 15 down. If I go 8 to the right and 15 down, I would know this is x. If I go 15 down, I would know that this would be negative 15. Yes, you can actually have a negative side length in the context of this. Basically, it's just letting you know your direction. You could then use the Pythagorean theorem, 8 squared plus negative 15 squared equals your hypotenuse, and we get 17. Now, remember that r, your hypotenuse, is always positive. Now, whether you use the trig functions of cosine being x over r and sine being y over r, or use Sohcahtoa, it does not make a difference. If we were looking at sine, sine would be opposite, which is our y value, over our hypotenuse, which is your r. And you would need to write sine of theta equals, and then put your answer down. Cosine of theta equals, and then cosine, remember, is adjacent, or x, over your hypotenuse, or r. Tangent is opposite over hypotenuse, or y over x. Cotangent, you got to flip your tangent one upside down. Secant, you got to take your cosine one and flip it upside down. And then cosecant is the reciprocal of sine, and you got to flip that upside down. Then we also have our quadrantal angles. Those are the angles that end up on the axes. So our first one is 0 degrees. Then if we go straight up, that's 90 degrees. Go all the way to the left, that's 180 degrees. Go all the way around and go straight down, that's 270. Then you would have 360, and they actually continue on if you keep adding 90 degrees here. Any angle that ends up on your axes is a quadrantal angle. So let's consider the point over here that's on 180 degrees. I'm going to give it the coordinates of negative r, comma, 0. Negative r because you're going to the left. Well, r is normally your hypotenuse, and we don't have a triangle formed here, so it's hard to use Sohcahtoa for this one. But keep in mind, according to the definition of r, we need to go x squared plus y squared inside of our square root. And we had said that r is always positive. Well, when we do that, we get r being your positive r. Sine then is the y value over r, and 0 over 0, or 0 over pi is 0. Cosine is your x coordinate, which is negative r over r, and we get negative 1. Tangent is the y value over the x value, and 0 divided by anything is 0. Then we also have to take a look at the reciprocal functions. We need to take the reciprocal of cotangent, or reciprocal of tangent to get cotangent. So I'm going to flip my fraction upside down, and that's going to give me negative r over 0. We can't divide by 0, so that's an undefined situation. Then we have our secant, which is the reciprocal of cosine. So I need to go r over negative r, which ends up being negative 1 still. And then cosecant, which is the reciprocal of sine, and that would be r over 0. We can't divide by 0, so we end up getting undefined again. We're going to take a look at our reference angle. Reference angles are nice because it allows you to be able to work out a lot of problems without having the whole unit circle memorized. All you really have to do is just know the first quadrant. Your reference angle is always an acute angle. It's always an angle between 0 to 90 degrees. And it's always the angle between the x-axis and your terminal side of your angle. So if we look at 160 degrees, 160 degrees is over here. Your reference angle is between here and the x-axis. And you might be like, well, I have two options. Yep, that's true. Now, we have this angle here in green. We also have this angle here in yellow. However, your reference angle is always the smaller of the two because it has to be smaller than 90 degrees. So your reference angle is the green. So basically you ask yourself, well, if I'm at 160 degrees, how far away am I from the 180? And that is 20 degrees. Same idea over here. It's how far you are away from the x-axis, and it's always the smaller of the two angles. So you're at negative 110, which means you're 70 degrees below your 180 degrees here. Because the negative 110 and 70 would have to add up to this angle here. So your reference angle is 70. Remember, reference angles are always acute, so that means they're always positive. So here we're at 275. You could either go to the x-axis over here, or you could always go to the x-axis over here. But remember, you always go to the one that's closest, or choosing the smaller angle. So here we are 85 degrees away. Because remember, going straight down is 270, so that's 90 degrees there, and we're just 5 units beyond that, so then it's 85 degrees. We also then have reference angles when we're dealing with radians. If you are dealing with a radian here, your answer is going to be in radians. So your negative 3/4 of a pi, going all the way from here to here would be a full pi. And so how far are we away? Well, we're 1/4 of a pi away. Reference angles will help us with this. We don't necessarily have this one memorized. But what is our reference angle? Well, it's 60 degrees, and you're supposed to have the cosine of 60 degrees memorized. And so you should have that memorized, and you're going to say it's 1/2. Now all we have to do, once we get this from our memorized stuff in the first quadrant, we have to decide if it's positive or negative. So that's where we look at where negative 60 degrees is. And is cosine x or y? Remember, cosine deals with x. And in this quadrant here, x is positive. So your answer is positive 1/2. Evaluating this, we're going to go to 5 pi over 4, which is here. How far are you from the x-axis? Your reference angle then is pi over 4. So you're going to look at the cosine of pi over 4. That's one you're supposed to have memorized because it's cosine of 45 degrees. And you end up getting root 2 over 2. Now you have to decide if it's positive or negative. This is where 5 pi over 4 is. Remember, cosine is x. Is your x positive or negative in this quadrant? X, because you're going to the left, is negative, so your answer is negative root 2 over 2. Looking at this one here, there's a couple ways we could do it. If you have your tangents memorized, then it's real easy. If you don't have your tangents memorized, we can use cosine and sine. Our reference angle would be 30 degrees because you're 30 degrees below your x-axis. So then we're looking at the cotangent of 30. If you wanted, you could look at that as cosine of 30 over the sine of 30. Cosine of 30 you're supposed to have memorized is root 2 over 2, or root 3 over 2. Sine of 30 is 1/2. So now you have a fraction divided by a fraction. Instead of multiplying or dividing by a fraction, you multiply by the reciprocal, so you're going to multiply by 2 over 1. The 2's are going to drop. You're going to be left with root 3 over 1. Now you have to decide if it's positive or negative. When you're looking at this quadrant here, sine is negative, cosine is negative. Also, your x and y are both negative. Remember, tangent and cotangent, you're dividing x and y. If you divide two negatives, you get a positive answer. So you end up with just positive root 3. This one here, cosecant. Oh, well, our reference angle is pi over 3. Remember, cosecant's the reciprocal of, oh, that's a typo. Cosecant's the reciprocal of sine. You're supposed to have memorized the sine of pi over 3. So you know it's going to be 1 divided by square root of 3 over 2. Well, instead of dividing by a fraction, you're going to go 1, and you're going to multiply it by the reciprocal of this. So it's 1 times the reciprocal of that. Don't worry about the negative. We'll deal with that here in a little bit. But remember, multiplying by 1 doesn't change it, so we don't need the 1. Also, you don't want to leave a root in the bottom, so you're going to multiply by a special form of 1. Multiplying the bottoms, we get 3. Multiplying the tops, we get a 2 root 3. Now we'll deal with the negative aspect. And why is it negative? Well, remember, we were in this quadrant, and we're dealing with sine. Sine deals with y. In the third quadrant, you're going down, so your y value is negative. So then we're going to put down a negative, and that's it.